Okay, so we're going to do a quick introductory video into the beginning of circles. Most of this stuff you should know, but I just want to kind of refamiliarize you with some terminology and such that will help us in this unit. So a circle is from the Latin word circus, which means a couple things. It kind of can be loosely defined as a ring or a race course. Kind of makes sense because a race course is kind of a circular track. You go around a ring. Obviously, it kind of looks like a ring. So the definition of a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. Okay. So if you remember our distance formula, which of course is d equals x1 minus x2 squared plus y1 minus y2 squared, and I'm just bringing this back up because this will be used a lot in this unit. This distance always is going to be the same from a center to all the points on the circle. So if we think of our circle with a center here, all these distances to these edges would all be the same. So when we name a circle, we certainly just name it by whatever the center point is. So if this center point is D, this is what we call circle D. Or we just write out the word circle. Okay? So in this circle, we have a couple different parts. We have what's called the interior of a circle, which is all the points inside the circle. And then, of course, an exterior of the circle is all points outside the circle. So if we look at circle C down here, which points are in the interior? Well, A is in the interior, B is in the interior, C is in the interior, and D is in the interior, because they're all points inside. And that would leave E, F, and G to be points on the exterior of the circle. Now the circle also has a lot of neat segments that we use quite often, one of which is being a chord. A chord is a segment whose endpoints are on the circle. So it goes edge to edge. So like this AB is a chord of circle C. I could draw another one in. This would be another chord. This would also be another chord. It could go through the center. All those would be chords. Now a diameter is actually a special kind of chord. A diameter is going to be a chord that passes through the center of the circle. It also refers to the distance across the circle. So this one I did up here, this one would have kind of been a diameter. And this one down here, AB, is the diameter because it goes straight across through the center. It is certainly not the only diameter. This would be a diameter as well, as with this, as with this. There are infinitely many diameters of this circle. And of course, related to diameter, we have the term radius. So radius is a segment that has the center as one of its endpoints, and a point on the circle as the other endpoint. So it goes from the center to some point on the circle. So in this case, it is from C to A, so the radius is CA. This is different from the diameter because remember, diameter would go all the way across. We should also, of course, know that the diameter is twice as long as the radius. Kind of an elementary topic, but hopefully something we definitely remember. So again, just to kind of continue on this radius thing, like we said, all radii of a circle are congruent. They're all the same. And the diameter is 2 radius, or the radius is half the diameter. Now another kind of less frequently used term is what's called the tangent line. Now a tangent line is a line in the plane of a circle that intersects a circle at exactly one point. So if you have a quarter or some kind of coin like this, and you lay your pencil next to this coin, just at one point, it only hits at one point. It only intersects the quarter at this one point up here. This is what we would call tangent. And this point where it intersects is what's called the point of tangency. So here you see circle C has this tangent line which intersects only at this one little point. A common tangent line could, of course, have one line. So this line, AB, could be tangent to two circles. It's tangent to circle A, and it's tangent to circle B. Now there are a couple different types of tangents. One is what we call a common external tangent. So if we take these two centers, in this case A and B, and we make a connection between those, as long as the common tangent does not touch them, we call this a common external tangent. So it doesn't intersect this segment that connects the two centers. If it does, so here's again this random segment, which really doesn't have a name, between the two centers. If it intersects that, then we call it a common internal tangent. External, outside of this segment. Internal, it would of course intersect this segment. The last kind of line we deal with is what's called a secant line. Now a secant line is just any line that intersects the circle in 2 points. So it's just going to basically pass through the circle. So AB would be a circle, or a secant, pardon me. Here's another one, DC. I could have AC. Any of them could be a secant. It could go through the center, that would be fine too. Any of those would be secant lines. Now another term we use a lot in circles is what's called concentric. Concentric basically means same center. So if you look at all these circles getting larger as we go out, they all still have this same red dot as its center, they just get larger and larger and larger. This kind of brings up a very interesting fact that all circles are similar. So all circles are basically the same shape, just different sizes. So two circles are congruent if they have the same radius. Should make sense. If they have the same distance from the center to the outside, I can move them so they basically lay right on top of each other, so they would be the exact same figure. So we have lots of ways circles can intersect. So I'm going to draw some of these for you so we can kind of get an idea of how circles can intersect. Two circles can have no points of intersection. So here is circle D, and here is circle F. These two circles have no points in intersection. They don't meet. The edges of the circles don't touch anywhere. Now two circles could have exactly one point of intersection. You can have two circles, if they only meet at one point, they have some kind of tangency. So we could have, when they have an internal tangent, where I have a circle here, we'll call it circle A. And let's say I have a little circle here that only intersects at this one point over here, circle B. So because those two circles only meet at one point and they're inside each other, we would say those are internally tangent. If they're externally tangent, we have a circle here, and we have another circle here that basically touch just at one spot on the outsides. So those would be called externally tangent. So maybe circle E or C and circle M. Those would have an external tangent. Now, two circles having exactly 2 points of intersection, that would be probably the easiest one. So if I have one circle here, and then I have another circle comes across like it, then these meet in 2 spots, here and here. Kind of like a Venn diagram, but they definitely meet in 2 spots. Now, two circles can have infinitely number of points, but the only way that can happen is that basically they're right on top of each other. So here's my first circle. And then I'm going to put another one right on top. So these two circles would have infinitely many intersecting points. So hopefully this was a quick review of just some different parts of the circle. If you have questions, please let us know.